Hello everyone. In this video, we will see the response of a RL circuit for a step input voltage. Here the step input voltage is going from 0 to V volt at t is equal to 0 seconds. From t is equal to 0 minus till t is equal to 0 minus, that means here the input voltage is 0 volt. That means input voltage will be replaced with the short circuit, and here I am taking a inductor which is not initially energized. Okay, so till t equal to 0, the VL voltage will be 0 and current flowing through the circuit is 0. That's why IR is 0 and VR is also 0 voltage across the resistor. So here IR is equal to IL equal to some I, that is because there is no other parallel paths, so there is only one current flowing through here. So before proceeding further, we need to understand few things. So for frequency 0, so if the frequency is 0, so how the inductor will act, how the capacitor will act. So inductor acts as a short circuit and capacitor acts as a open circuit. As frequency tends to infinity, inductor acts as a open circuit and capacitor acts as a short circuit. So this is the basic difference between inductor and capacitor with respect to frequency. So let's take at t is equal to infinity. That means as t tends to infinity, we know that this step is a will look like as a DC voltage. That means frequency 0. At the frequency 0, we know that what is the we know that behavior at the inductor is short circuit. So at t is equal to t tends to infinity, I can replace inductor with some short circuit, and this is v in is equal to v volt, and R, because this is a short circuit, the current flowing through the circuit is equal to v in divided by R, which is v divided by R, and the voltage across the resistor is v in only. So that the IR is equal to v divided by R, and voltage across the resistor is v in only, v in equal to v volt. And let's see what's happening as t is equal to 0 seconds. So as I early told, so there is a sudden change in the voltage. That means there is a discontinuity here. So this region has a components of infinity frequency. That means here I can consider this as a this term at t is equal to 0, the input signal has a infinity frequency signals. So because of that one, what will happen, because if I have a infinity frequency, inductor acts as a open circuit, so I can replace at t is equal to 0 inductor as a open circuit. That means I can replace my circuit with some resistor, and there is some open circuit which is because of VL. So this is open, the current will be 0 ampere because there is no closed path to flow the current, so the current will be 0. So IR is equal to 0 only, but VL you can see that V in only. So VL will be V in. So VL will be V in, which is equal to V volt. Then we know that at t tends to infinity, VL will be 0 volt. So this V in eventually from V in it will go to 0 volts. In the same way, the current initially is 0 ampere, eventually it goes to V by R. So voltage across the resistor exponentially rises and reaches to V in. And what is this time? So we have the time constant here. So the time constant of the circuit is, for inductor, this is L by R. So this is the time constant tau. Okay, so within we generally say that with 5 time constant it almost reaches the um, uh, the circuit will get stabilized with almost with 5 tau time constant, the circuit will almost get stabilized to that steady state conditions. So then how to find this time constant tau? So we generally need to replace voltage source with short circuit and current sources with open circuit, and find L equivalent and R equivalent. So here L equivalent is equal to L. If I replace V in voltage source with short circuit, there is a R. So the time constant will be L equivalent divided by R equivalent. So L equivalent here is L and R equivalent is R. So that's why time constant tau is equal to L by R. So this voltage VL, so exponentially decays and reaches to 0 volt. And this is the, we can consider this is a 5 tau time. Approximately at 5 tau time, the VL will reaches to 0 volt. Here I have simulated the same circuit with the Vn of 1 volt, which is going from 0 to 1 volt, and the R is equal to 100 ohm and L is equal to 10 milli ohm. We can say that VL initially reached to V in, then it eventually went to 0, and IR is equal to during the discontinuity this was 0 ampere, then eventually it reached to V by R, which is some 1 volt divided by 100 ohm, like 100 milliampere.